Yesterday, as I finished most of the study guide, I have only 5 chapters left. If you go and check this one here in iCollege, you will find in the announcement, the first announcement is the study guide. Study guide from chapter 1 to 10, but I'll finish up to tonight up to chapter 15. Chapter 16 will not be, as I said, part of the, yes. All of it multiple choices, yes. I will put 20 questions. I saw some other instructors, they put it like 70 questions. 70 questions, you need about a couple hours, correct? No, that's 20 questions for 1.5 or 2 hours. I have to check the time. I'll let you know about the time. The good thing about the whole thing is it's not standardized exam. I'm the one is putting this exam, and I'm the one I'm going through the points of the study guide. I put 10 chapters here. This study guide, final exam study guide, up to the 10th chapter. And tonight I will promise you to finish up to the 15th. 16th will not be part of the final exam. As I said, it's more or less a political science class than the science class. So about rules and laws and regulations. I mean, you can review it by yourself, but it's not really per se science. I don't know why the author is adding this to his chapter, but that's just that's a choice of the author itself. So we'll go through this together. I'll open the chapter, and then we'll go through the main points of the study guide. I copied the announcement inside Microsoft Word here, and what's happened is those headlines of each chapter is really made to remind you of the final exam being what will be definitions, more or less definitions. If there is a relationship between one condition to the other condition will be mentioned, but mostly is, as I have seen, the content is totally different what I'm teaching chemistry. Chemistry, we have a lot of math, we do formulas. So here you have more or less is definitions. Put you the issue and then put whatever definitions, and sometimes relate some condition to the others. Okay, like pollution, what the risk of those pollutions and what they health-wise, financial-wise, and all the stuff here. So we'll start with chapter 1 as we go, and as we go we'll have plenty. So we have how many now? We are in the say 9. So next week, and everybody knows when is the final is? Everybody knows? I put this one in the iCollege, correct? When? April what? 30th. April 30th, the same time, 11:30. And the time, I think, is 1.5 hours, but to 2 hours. That's what I say in chemistry. But I have to check in the environmental science how much. I think minimum is 1.5 hours for 20 questions. But as I said, some instructors, I looked at how many I asked. They said 70 in 1.5 hours. I think 70 in 1.5 hours, you will not be able to finish them on time, and you will just guess some of them, and then you will miss some of them, so you'll not be able to finish all of them. All those are multiple choices. There's a lot of questions. So for me, I'll put 20 or 25 maximum, 20 to 25 questions. That's all. That's all for 15 chapters. So let's start with chapter 1, and we'll look at the points we just have here. As I said, the study guides are points. Mostly is the final exam is mostly is multiple choice. I mean, all of it multiple choice, but mostly is definitions. And sometimes if there are some conditions related to the other conditions, we'll ask you about the conditions, and the answer is one of the multiple choices given. So the answer always will be one of the multiple choices given. there will be always one multiple choice as a correct answer, not two or three multiple or all of the above. All of the above, one multiple choice. Yes. The study guide? Yeah. No, not extra credit. You have plenty. We can use it during the final or no? Yes, we have to study the study guide. For example, I will open now chapter 1. We'll finish today as much as we can, and we will have to the 22nd. We will have about 2 weeks almost. So we'll be finishing all the chapters, reviewing all of them. And mostly, as I said, is questions are mostly definitions. The whole textbook is based on definitions, and very rare just explaining the relationship between two items or three or their effects among them, those conditions. So, but mostly, I said the book is I mean the whole book of the environmental principle of environmental sciences definitions. You will see it yourself. You can look into it. That's totally different from chemistry, which is chemistry has a lot of math. We have a lot of formulas to apply to look on those formulas. So there's a lot of chemistry is part of combination of physics and math, mostly physics and math. Okay, so this class is mostly definitions about this. So let's take chapter 1, and then what we will do here, we'll take the whole detailed PowerPoints, not the, when we had the lecture, we had, because the time is always restricting us from going to have, for chapter 1, for example, you have over 70, 80, or 90 slides, so we'll not be able to finish the chapter on time. We took the extract one, but the final exam, we'll go back and look at the detailed ones, detailed PowerPoints. We'll start chapter 1, and then what I will do here, I will split the screen into two. This one is the first screen, and the second screen will be, or this, whatever. So this is this, and then we'll have the second one here. So though you can split the screen in two, so and then you can see whatever you have. So I'm not doing this, I'm doing the PowerPoint. So let's put the PowerPoints here. Chapter 1. Okay, let's download chapter 1, the detailed one. Chapter 2, no, chapter 1. Just bear with me a little bit. So let's say chapter 2. We have to go back to chapter 1. And meantime, don't forget to finish up the online assignment. You can access it within the iCollege. You can access it from within the iCollege. Let's download chapter 1. Okay, I'm splitting this and then going back and forth between those two screens. So here it is, and okay, so now we have split between, I will be back and forth between the two, between the study guide at the left as in Microsoft Word, so you can look at it. That's in the announcement, but you can copy all of it in Microsoft Word and keep it in your desktop or iPad or laptop. So the first thing in chapter 1, definition of environmental science. We covered this one. I think chapter 1 we covered most of it last week, correct? Last Monday, I mean, not last week, last Monday. But this one here is definition of environmental science. And what's the key of the whole environmental science is us, human. Human is the key, is the core of the environmental science, is the well-being. It's a science that's really interested in the well-being of the, we'll not go case study or something. So here it is, it says, what is the environmental science? And I told you it's related to all around surrounding us, and as the well-being and the mankind and its surroundings. And that's the definition here. Here's the definition here, and then let me use this one here, guys. So the answer for this question, if multiple choices, that's the answer of the first. Whoops, don't worry, we'll come back. So so definition. What's the environmental science definition or question? And you can see the question, the answer is there. So you'll get a couple of those, tricky, not tricky, but really multiple choices. One of them, this is the correct answer, but one of them is just misleading multiple choices. But always is environmental science is about the mankind, about that's what environment we are living in and our surrounding. So that's the answer here. Study, it's a science, study our environment, which our place in it. The mankind is the most important thing, and the surrounding of the mankind. That's with regard to its human mankind with its well-being and good health. So that's the first definition of environmental science. Take this one out. Let's go to the second one. Important themes in the environmental science. What those are important themes of the of environmental science. So you can see I did not cover the whole thing. This slide's about, I think if you look, this is 76 slides. That's large slides. So I took the very important point of each chapter. So important themes of environmental science. You go there and look at the whole thing, and here we are. So the major themes are, again, that's we are repeating ourselves. The humans are the center and the core of this environmental science, or this type of science, correct? So that will cover this one here. So what are major themes in the environmental science? We have three major themes or subjects, correct, or points of view. Environmental quality, human population well-being, and natural resources. Those are the major point of views of environmental science, or the core of the environmental science. Those three themes. So as we go for the study guide, I'll tell you from where you can study, correct? So those are the themes. So sustainability, I'll take this one out. We'll go for the third topic. Okay. Any question? Ask me if you have any question. And this will be a closed book, so that's the reason you have to memorize a little bit. It will be closed book, and as I said, it's 20 to 25, not 70 or 80. I was shocked when I see 70. We have in chemistry 70 questions, but that's about 2 hours exam, and students are not performing very well. It's just too long, and then too many questions, too many calculations. Students are lost in those type of questions. So the exam should not exceed maximum of maybe 25. That's the final exam should be like this. So this is the second point of view, or the second study guide item in chapter 1. I'll take this one out, go for the third one. We'll go for the third topic, which is sustainability. And we are looking for what? The definition. As I said, the whole textbook is about definitions, as you have seen, mostly definitions. So I'll come here, then scroll this down. Those are the major 3 themes. Speak about them in details, as I said. Environmental quality, that's one subject, one point of view. Underneath this environmental quality will come climate change, clean, fresh tap water, and air quality. And the second theme is population growth, correct, and well-being. And those are the points here that will come under these. And this is the third theme is natural resources, and what's come under natural resources. So let's go and look at the word sustainability. What do we mean by sustainability according to the author point of view? So you go here, environmental and political problems. Environmental and political problems, air quality. That's all those political problems, hunger, and biodiversity. Okay, so air pollution, sign of health, progress. I'm just looking at the word sustainability, and I found it here. Okay, so this is whatever I have here, it's given to me here, and this is the answer for it. That's the answer of this according to the point of view of the author of the book. Sustainability is a search for long-term ecological stability and human progress. Okay, and that's what's that's the core of the environmental science. Correct. That's the core, the heart and the core of the environmental science. It's always human is become the first, first issue, and their well-being. So this is the definition of the third one. Okay, guys. So this is the definition of the third one. So any question you have? Any question you have? So let's go for the basic principles of science. Okay, so there are basic principles of sciences. This is in general, not environmental science, but all type of sciences. And in some extent, engineering as well, because engineering just science plus math. What's really engineering is science plus math. You add the math to the engineering, to math to the science courses, you get engineering. So nothing really different from whatever you have studied. So I hold a chemical engineering degree. It's mostly chemistry plus math. It's a lot of math and chemistry. So you have to take a lot of chemistry classes too. So we'll have this basic. Let me just go here and look at the basic principles. So now we defined the sustainability here, and we'll go and look at the basic principles of sciences. As I said, not all the slides are covered. Mostly in my opinion, so the most important stuff we covered here. So this is, we start with the science, help us to understand the world. Basic principle of science is here. So now this will come to will answer from this. You don't have to memorize all this name, but what's the basic principles? You have the observation of real phenomena, correct? The managing of natural, the natural forces at work today are the same as those shaped. That's all this observation of real on the observable phenomena. And all those types here, you just transfer them in one sentence or two, okay? So those are the four basics of what? Of science. Now, there might be definition of those, I'm not sure, but the main thing is the basic science you observe, and that's what the scientific method is. You start observing, and then after this observation, you make hypothesis. After the hypothesis, you go to the lab, do experimental. So the observation is qualitative of data. And then you go to, then you make hypothesis based on this qualitative data. Is not enough. You have to go to the lab, whether it's biology lab, chemistry lab, physics lab, depending on what your hypothesis is, which is a short statement about what you have seen. Okay, that's what hypothesis is. Short statement about what you have experienced and seen, and you made your statement. So this statement has to be tested. So in order to test this hypothesis, I have to go back to the lab, whatever the hypothesis is all about, all science labs and engineering. So go there and then test this hypothesis, doing some experimental data and gain some analytical data, which is, we call it qualitative. Now we started with qualitative, no data whatsoever, and then we made this short statement. Short statement is tested in the lab. We gathered data, now we have quantitative. The combination of qualitative and quantitative is tested further, not by the person who had made those, but by the other scientists, to help this scientist in his hypothesis. So if many scientists all over the globe use the same conditions, the same thing, that's the person who had the observation and made the data and collected data, if they get the same data, qualitative and quantitative, they will elevate this hypothesis to what? Theory. Correct? Now the theory can be accepted, okay, or can be rejected. Now depending on the time, the theory, if it's proven it's not changing, because technology can really expose this theory and can test this theory. So technology, with the advances in technology, this theory here can be really exposed and can be tested. If all technologies within, say, in the range of 50 years or so, has no effect on the qualitative and quantitative data and is proven to be true all the time within this long time, so this theory here is elevated to be scientific what? Scientific law. Scientific law. Let me just write to you the steps. We make observation. Correct? Let me take this one here. First, you made an observation. I think this one here in the way the writer have written it is in different from what we teach in physics and chemistry. Physics and chemistry we have different steps. So that's what we teach in chemistry and physics and engineering. So I made an observation, and this observation is I gather what from this. I gather what? Gathering Qualitative. Qualitative, no numbers. Qualitative means no numbers. Data. Correct? Then I go from there. Number 2, I make a short statement. This is hypothesis, which is really a short statement about whatever I have seen, whatever I have observed. Correct? Then from there is my hypothesis being tested. Number 3, testing the hypothesis. So the book is following us, but a little bit modification from whatever we teach in physics and chemistry and engineering. So I test this one here. So number 4 then, this one here goes what? Gathering what? Was here. After 3 say gathering here this time. Gathering quantitative data. So observation, which is I gather qualitative data, no numbers, correct? Hypothesis, then after that I made a short statement about what I have seen, observed. Then I make this statement, and then I go after that to what? Number 3, to test this hypothesis. This statement has to be tested. Correct? Then I'm gathering quantitative data. Correct? Now, number 4, I have to examine the qualitative and the quantitative data and make up with a statement, this time stronger core theory. So a theory is made. A theory is made based on both qualitative and quantitative data. So I gathered those in the lab, and then I made a theory. Now this theory can be accepted or can be rejected. So who will do that? Who will decide this? Not me. I'm the one who had observed, tested everything by myself, and made this theory. Now this theory, acceptance or rejection of it, that will come with the other scientific community, will come to help in this. If they got the same data, the same data I got, then this theory is accepted. So let me everybody has this? Everybody has this points here? So number 5, elevation of this theory will be after acceptance for a long time by scientific community, by all over the globe. This theory here for a long time. This long time can be years, like 50 years, 40 years, not 5 or 10 or 20 years, because you have to assess this theory here for new advanced technologies. If every time with the usage of this new advanced technologies proven to be, this theory is not moving anywhere, it's always true, whatever we are getting, we are getting the same data with the new advanced technology. So after a long time, so this theory will be elevated to scientific law. So let's do number 5. Number 5, a theory is based on the qualitative, correct? Number 5 will be, can I take this one out? Now I need help from the scientific community. So now after this evaluation of hypothesis, I made gathered the data. I made stronger now statements, not the hypothesis I started with. My hypothesis now proven is correct. So I go the next step, which is I made a theory based on my gathering qualitative and quantitative data. So gathering the theory, those data here. I push this observation to be now not hypothesis, but to be theory. Take this one out. Now I said this theory has to be tested. Number 5. Theory here is to be tested by the scientific community. So by the scientific community through the globe. So, and if it turns out this theory is holding with all the technology advances, then I can, and with the help of all the community, a scientific community, we can elevate this status of the theory into scientific law. And most of the time, they will honor the person who had made the whole effort. Correct? For example, Einstein theory. Correct? Lewis that structure theory. So always you honor the person who started the whole thing first, although that's not his effort only, but because the other scientific community worked with him and then proven that this theory, this observation is correct, and all whatever this elevation, this over 50 years, 60 years, and scientific law, they don't change really. They stay for a long time. We have scientific laws, they are old as 100 years or more, or 200 years. So, theory is tested by the scientific community through the globe, and if this theory here if this theory does not change, oops, sorry. If this theory does not change by time, during long time, actually is over 50 years or so, 50 years. Then you go for where? Number 6, you go for what? Scientific law. So the theory is elevated, theory is elevated into scientific law. So you have those steps all the time, and those steps are, you see it in physics, engineering, and chemistry. That's what's happened. And to honor the person who started the whole thing, this theory most of the time take the name of the scientist. Correct? Fermi as this semiconductor, Fermi law, Faraday, Newton law, Einstein law. So all those scientific laws are holding to the scientist who started with, but it's not the effort of only one scientist. That scientist, he or she started. We heard about in nuclear chemistry, the isotope radioactivity. Madame Curie and her husband, she did most of the work. So then the name is the owner herself, so she has her own theory there. So always the theory, the observation made, and then all the collection of the data, the beginner, the person who started this effort here will be honored because that's his work or her work to begin with. Correct, guys? Any question about this? So then the scientific law stays there. even if, despite all the, I mean, it will stay there even with, if you have a lot of advances, technology will not change. So scientific laws, here, a note here just in red. Scientific laws don't change per time. There are many scientific laws we know. There are over 100, some of them over 200, some of them over 300 years old. They stay with us, and some of them we have seen, but we don't know until now. We have the observation, but we could not. It's a puzzle. We could not really answer. And one of the of this year in Egyptian, what type of chemistry they use, what type of chemical they use to preserve the body of the pharaohs and their people in their palace. I mean, his families, all the pharaohs, most of their body kept for over 5,000 years. So we don't know what type of chemicals they use, what type of mixture they use to preserve all this body. So, but that's an observation. People are working on it for many, many years, but still the puzzle is still there. I think they used mixture of pigment or colors coming extracted from the plants. All this here, poison are extracted from the plants. Coloring dyes are extracted from the plants. So the plants has a lot of excellent resources for toxic, for poisons, and for coloring dyes, and for medicine as well. So plants has wide range of usage. So can I take this one out? Everybody has it? Any question you can ask me. So it is. So that's the basic principle of science. The steps of scientific inquiry. That's, I think, it's covered indirect. If you look at this, this is the principle of science, as I said here. So, and we mentioned the step of scientific inquiry. That's really inside within the basic principles. So the basic principles are there. So I will say, if somebody will ask you about the definition of those, you might be able to answer it. So here it is. Let's see. So here it is, the steps of scientific inquiry. So that's the start, the observation. Those are the steps. And make hypothesis, second one. And those are the steps here. 6 steps, correct? But ours, whatever I have explained to you, is a little bit of whatever we teach in physics, engineering, and chemistry. The last step in physics and chemistry and engineering, the last step here is this is here. We have scientific law. Scientific law. We have to record this one. The person who had started the whole observation from the beginning, he or she, they need the help of the scientific community through the globe. So they have to test whatever that person said. So, and they have to prove when that's really true or not true. So, and it's proven true. Most of the time, the person who started the whole thing will be honored with this scientific law name. So the scientific name, most of the time, is carrying the scientific law name is always carrying the name of the first person who had really discovered this observation and tested this observation, correct? So, but it's the same step. I mentioned that for you. So this is chapter 1. Anything about chapter 1? Anything about chapter 1? And I think that's very important to know this. That's the best points of chapter 1. So chapter 2, see here. Chapter 2, ecosystem. What's the definition of ecosystem? Well, you come here, and those are the detailed PowerPoint, not the short one, the detailed one. We did not have any case study. We could, but we don't need it. So case study, in my case, I wanted to go to the extra credit to get insight about those chemicals, about the reactions, about biology, because we in this extra credit we have a lot of biology and chemistry experimentation. So anyway, so we did not do case study. So we are looking at the first one. What is the ecosystem? We need the definition of ecosystem. So the definition is given to you here. This is the answer here for, whoops, oh, the answer for this. So the answer for this, for ecosystem, is given to you here, correct? Ecosystem from ecology plus system, correct? So this is two combined words. It's a complex assemblage of animal, plants, their environment through which material and energy move. That's the ecosystem definition, correct? So we'll go for the second one, systems types. Any question you have, stop me. You can stop me anytime. So I get a request for a couple of the students. I was very happy to extend those quizzes. So I'm repeating myself again. If you have missed any of even if you have missed the midterm, I'm willing to reopen it. Some students, they get scared and they don't talk. They miss some quizzes and they are shy to ask. You can ask. I'm not doing this one in this class. I'm doing this through my 28 years in all my classes. So I give the students second and third chance. So if you have, I'm repeating myself. The good thing I got through the weekend, this week, couple of requests. So there were students there that are shy to mention it. So, but if you missed any of those outstanding quizzes, you did not do, so let me know. So number 3, systems types. So we define the ecosystem, correct? Bless you. So let's go for this second topic, systems type. So here it is. So we'll go and look after the definition here. We are looking at the systems type. So it is, okay. System types are what? System type consist of a simple system is made of 2 things here. And it's given to you here. This is the first type. This is the second type. Okay. So the state variables and the flows. The flows, when this is a movement of pathways in which natural resources or the resources move from one state variable to another one. And the state variable is called the compartments, which store resources such as energy, matter, or fresh tap water. That's an example. So you have 2 types of systems. You have 2 types. Yes?
So if you even know the system, you need to know like the system and what they do.
I will guess you should know what they are really doing. So yeah, you have to know this. It's not enough just to know what type. But it said here system types is connected to whatever they do. So yeah, so whatever they do. Okay, guys. So the first one give you what says they are, what type of they are storing, and then the second one how they flow from one compartment to the other. Those are two types of system. So the second one, atom structure, atomic mass, atomic number, and isotope. Somebody had taken chemistry? No, not yet. No, nobody is planning to take chemistry? No, at all? Not at all? Okay. Well, chemistry is very fun. And then the chemical engineering even much more fun because you add math to it. So it's math and chemistry, chemical engineering. So let's do a number, and then we'll do some examples so you can follow me. The atomic structure, and that's here, guys. Go and look. Feedback, emergent, life, structure of an atom. So an atom is made of two components. So one component is a major component first is the nucleus. Here, dot. And surrounding with that's the heart, that's in the middle. It's not in the middle, so I have to put it somewhere in the middle. I apologize. I'm not a good artist. I was one, but I lost it through the years. Nucleus is Greek, adopted later on by the Latin. Remember, the Greek is the older than Latin. Latin came after the Greek language. So Greek, they put nucleus, the word nucleus, and the word atom is a Greek. It's a Greek word, meaning the smallest particle of a matter. So the atom, this atom here, this word atom here, guys, that's a Greek word, meaning the smallest particle in a matter, whatever the matter is, gas, solid, liquid, plasma, whatever the matter is, the smallest particle, the smallest item inside this matter is called atom. So atom is a Greek word. This is the smallest, ever smallest particle or item inside the matter, whatever the matter might be. Liquid, solid, gas, plasma, whatever the matter. So the first one is the nucleus. Nucleus is the center of the atom, correct? And this nucleus we have protons, and then we have neutrons. And their symbol is, this is small, tiny. Here is different, put it capital N, that's fine. We'll put it capital N as the author is making. And the protons is capital B, and it has a charge. Neutron has zero charge. That's a charge here, no charge. But it has a mass though. We'll look into this. So inside the nucleus you have these two items. Outside the nucleus there's small tiny negative particle here spinning or rotating around this nucleus, correct? Those called electrons. And they have the symbol of E minus. According to the book, we have small e. We write them in physics and chemistry and engineering, small alphabet, but the book is using them. So the charge of the electrons spinning around negative. Inside the nucleus you have a proton and the neutron. Okay, so the nucleus itself is an empty space. An empty space. I give my students the idea about how to visualize an atom. Somebody has seen a movie long time. Honey, I Shrunk the Kids. Somebody has this movie? You have seen it? Okay. So imagine you have shrunk yourself to the nano scale. And you have a submarine, you shrunk this submarine in the nanoscale. You squeeze yourself in this nanoscale submarine, and you drive inside a piece of wood or a piece of iron, and you go to the atom of an iron. So the first thing you will see, nothing, everything dark. Everything inside the atom dark. You cannot see nothing. The only thing you can hear is the hissing, and the electrons are moving with the speed of light. You'll hear something goes zzz, like a beehive near the bees near their hives. When they gather, start producing honey. Zzz, that's what you hear. But all your equipment can record nothing, zero, everything dark. Are you following me? That's the atom. That's really the atom is. And then all of a sudden you drive because you are going astray. There's no guidance. Everything is dark. Your equipment is not working. And then you hit a big rock, and your submarine, yourself bouncing off this rock or this center of this. That's the nucleus. The nucleus is the center of the atom, where all the mass of the atom inside this nucleus. The whatever you are hearing for the movement of the light, those particle electrons, they are almost massless. They are very tiny mass. Correct? So they are less than 2⁻⁻24 grams. Can you visualize this? 10⁻24 grams. That's very, very tiny amount, correct? Less than that. So around less than even 0.1, less than 1 even. Now inside the nucleus, this one protons, they have the highest mass, which is 2⁻⁻24 grams, and the others 10⁻24 grams. So the nucleus has all the mass, and this one here less than this, less than 2.10 grams. So the whole mass of the atom is inside the core, inside the nucleus itself. Correct? And most of the time, the mass of neutron very close to the mass of the proton. Correct? The mass of the neutron, we speak about the mass, not the number. The number is different. Correct? So that's the structure of an atom. Any question about this? You get the idea? Good. So that's an atom here. And I can tell you Rutherford, the periodic table, here is one of his work. He has this idea. He did, I think, in Berkeley Federal Lab. So he worked on this idea, and he came up with the idea in his notes. He said, imagine an atom is like a football stadium. Can you see that? Huge football stadium. In the center of this football stadium, in the center line, in the middle of this, from as you take it from the top from right to left or left to right, whatever. So it's sitting a mosquito. Can you see a mosquito in the center line? No. That's the nucleus. And in the last row up, the spectators are sitting and watching. Those are electrons. Everybody's following me? So Rutherford, he got I think he got a Nobel Prize, and he was honored. One of the periodic table carries out his name, Rutherford. Rutherford Yum, Einstein Yum, Berkeley Lab Berkeley Yum. Those Yum, I-U-M at the end, that's to honor the Faraday Yum, Fermi Yum. So it's a lot of scientists are honored in the periodic table with their contribution. Correct? So, but anyway, so in the sense, if you look at the whole atom here, the mass in the middle, which has protons and neutrons, and the outside is electron. Electrons are negative charges. The neutrons, the word neutron is neutral. They have no charges, zero charges, and the proton, they have positive charges. Are you following me here? So now, with this in mind, as I said, you have a big football, as he noted in his notes, big football stadium, and the middle line is mosquito, that's the nucleus. And those making speed of light, those moving around the nucleus, those are the last row spectators watching the game. They are not involved with anything. So they are really held with the positive charge of the neutrons inside. The protons inside the nucleus is holding what? Is holding those negative charges. And those charges in neutral atom, they will be equal. If I have 3 electrons outside spinning, rotating around the nucleus, I have 3 inside what? Inside, bless you, inside the nucleus. So that's a neutral. 3 positive inside the nucleus, 3 negative outside the nucleus. Correct, guys? So that's about the structure of an atom. Any question about this? Any question, guys? Any question? That's in general, that's an atom definition. Now let's look at the atomic mass and atomic number. So can I take one out? Nobody has it. So the proton is inside, positive charge. They are positive charge. And the neutrons inside the nucleus but have no charge. The outside is a negative charge, electrons spinning around with the speed of light around the nucleus itself. As long as we have a neutral atom, that means number of the protons inside, positive charges, equal the number of electron, negative charges outside. That's in a neutral one. So, here's the periodic table. I did not realize. That's, where is 104? This is here, guys. Can you see it? RF, Rutherfordium, is the father of the new atom discovery. So here it is. He is honored with this name. And if you look at the old name here, you'll see a lot of scientists. You have fermium, you have einsteinium, you have berkelium, and you have a lot of names of scientists here. They have been honored. They have been honored with their contribution. Correct? So now, this said and done. Let's go and look at the atomic number and the atomic mass. I did not go through this at the beginning because they said that this professor's chemistry is teaching us chemistry, but now I did realize that that's inside. But you have to know just basic chemistry. Somebody had studied in the high school some chemistry? Very few. All of you? No? Okay. Okay, so that's good. Well, I did in my high school time, which is a British system. Then I went to German system to learn chemistry plus engineering plus math. That was engineering, chemical engineering. So here, guys, that's long time ago. So now, what we mean by atomic mass? If you look here at the periodic table, and those are very good, valuable elements. You know, titanium, that's all the airplane is made from. The metal is very heavy, not very light, but very, very resistant to any breakage. So airplane is made of titanium. Then you have 2 numbers, guys. One in the top said 22, correct? I'll put the number for titanium. So this, let me put this one here as an example. Don't consider this a chemistry class. Just I want to go through this. I do not want to go to chemistry class, but we have Ti. Always a symbol in periodic table for the elements, the capital alphabet and the small one has to be Second one is small one. You can't have two capital alphabets. One is the first one capital, the second one is small. Not every time you have two alphabets. Sometimes you have one alphabet. Carbon, C, one alphabet. Nitrogen, one alphabet. Correct? But the majority of the elements you can see in the periodic table, they have two alphabets. One capital, the second one is a smaller one. So this titanium has two numbers. One in the top, correct? And one at the bottom, which is 47.942. Now you ask me about what's the unit of this. Well, the unit of those here, the unit of this is AMU. So this one here called at the bottom, the bigger one number. This is the biggest by so far. And it has the biggest one called atomic mass. That's the mass of the atom of titanium. How much? 47.9. So AMU stands for atomic, M for mass, and U for unit. So those are really nothing less, is just the number of the protons and electrons. So when I round this one here, it has to be rounded to a whole number. You have to round it. This one will be 48. 48 AMU, which is atomic mass here, 48. So atomic mass of titanium here is 48, which is number of the protons, B plus number of the neutrons. Correct? Everybody's following? So what is atomic mass? Atomic mass is number of the protons plus number of neutrons inside the nucleus. Now we have the top one here. The same unit is AMU, correct? Which is called atomic number. So this one here called atomic number. So the atomic number here is number of atomic number is equal number of the protons in a neutral equal to number of electrons. This has to be positive. So memorize that for me here. If I give you an atom, because I saw the other professors, their final exam, they put this question, although they are not chemists, but they said the students should know this. So I got experience about how the final exam is structured. So they put this type of, they give you an element, will give you atomic number, atomic mass, and they will tell you to determine the number of neutrons inside this atom. So you know that the number of the protons is what? 22, correct? The number of electrons, 22. How about the electrons? How about the neutrons? Well, what you will have to do? Subtraction, correct? Subtraction. So I have 48. That's the atomic mass of both, proton and neutron. But the protons are 22. So how much is the neutron will be? 48 minus 22 will be what? Will be what, guys? 26. So let's pick up one that has really very importance. We talked about environment, nuclear waste. We talked about nuclear waste. Let's take uranium, and you tell me the number of the protons. But I will wait with that. Everybody has this? So that will come. That because I saw their final exams. They said, although they are not chemists, The professors I discussed, they are not chemists, but they said they should, basic knowledge of chemistry, they should, students of environmental science, they should have it. So I'm bringing this one to you. So we discussed this, the video will be recorded. Yes? That's titanium, Ti. Ti, here it is, titanium. Now, TIT, the spelling is the TITAN, titanium, IUM at the end. All the elements, most of the time, they end up with IUM. Not all of them. Carbon does not have IUM. Nitrogen is not. Oxygen is not. But majority. So let me take this one out. And then I'll tell you, you tell me now. That's maybe in the test. We don't know. So here it is. I give you U, and then I give you U is uranium. Now, you know uranium is a very important element that's used in the nuclear generating electricity in the nuclear plants. Very important. And it has two isotopes. We'll learn about the isotopes. So, in the top, it's, I'll put the same day here. So you have 92, that's atomic number. And in the bottom, 238. I give you the whole number. I will not give you a fraction, I'll give you the whole number. And you tell me, what's the number of the protons? What's the number of the neutrons? No charge. What's the number of electrons? So this is atomic mass. This is atomic number. So if you go to uranium, and I give you the name of it, all the time you'll see IUM at the end. Okay? So Faradayum. Rutherfordium. So they put the name of the whole scientist. Einstein as is, and then IUM. Rutherford, the same name, IUM at the end. So that's uranium. And this is IUM. Uran means this is a rock, emitting radiation rock. So Uran is German, same thing. Uran is a rock. It's emitting rock. So this is atomic what? Atomic number. And the other one is atomic mass. So what's the number of the protons? Somebody will tell me? We have here 92 and here 238. So what is the number of the protons here? The first one. 92. Perfect. Thank you. What is the number of neutrons? What is the number of neutrons? Somebody has it? Well, atomic mass 238 minus 92, correct? How much is this? 6. How much will be? 2 and 1 and 2, 6, correct? Am I correct? No, that's not correct. So how much is it, guys? 6 and 13 is 4. 4, correct? Is that correct now? Okay, so how much is how many electrons we have? Electrons in negative here. How many? 92. Perfect. So now we get the idea. The atomic number is 92, which is the same amount of electrons, and at the same time, the same amount of protons. The atomic mass is the sum of the protons inside the nucleus plus the sum of the neutrons inside. We neglect the electrons outside because they are almost massless. Not the massless, they do, but it's very, very small. Very, very small number. So, and You need another element? Another element? So let's take, we have, let's take another one. I want to show you here. Let's take one of the scientists here, fermium. So fermium is Fermi, the one who has to make the double semiconductor. So can I take this one here? So Fm, correct? So Fm is, the name of the scientist is fermium. Or fermium. I'm sorry. Yeah, fermium, correct. So atomic number is 100. And the atomic mass, how much is it? It's 200. You don't have to memorize this. It's 275. Or it's not, 258. So 258. The bigger number is atomic mass. So now you tell me number of electrons and number of the protons. I'm just quit, and number of neutrons. So, and then we'll call it off, and then we'll come back and do isotope. So we have plenty time to review. Very good review and very good. So what is the number of electrons here in fermium? That's fermium here, the scientist's name, and then the IUM at the end. Rutherford, Yum. Einstein, Yum. Faraday, the name of the scientist, Faraday, Yum. So IUM at the end. So how much is the number of electrons? How many electrons? 100, correct. Now we get the idea. Now we get the sense of it. This is protons plus, not plus, and electrons. They are equal in neutral atom. How many protons? 100. How many neutrons? 258 minus 100 is 158. So you get the idea. I'll stop here. I'll stop recording. I'll stop here because I have time to upload this video, and then we'll come and look at isotope. As the time goes, we'll go through all these points, so you'll be ready for the final exam. Okay, guys? So